on the next part of the study guide. This part's about direct variation. So your equation that goes along with direct variation is y equals ax, where a right here is the constant of variation, and the way we find that is we say our y divided by our x. So I'm going to give you some information to fill that part out. Now the graph of a direct variation always goes through the origin. So that's what you're always looking for when you look for direct variation. So for 1 through 3, I just asked you to write the equation for the following. To write the equation, I'm going to need that a value. So I'm going to need y divided by x. But what the equation should look like is y equals ax. So I'm going to use one of these formulas to find the other one. So my first one says y varies directly as x and then gives me an x and a y. So all I have to do is say y divided by x. So 6 divided by 2, and I find that a equals 3. Now write your equation, y equals 3x, and you're done. Now the next one, I've switched up variables on you, but your y always comes first, your x always comes second. So now anytime I was talking about a y, I'm talking about an n. Anytime I was talking about a x, I'm now talking about an m. So y divided by x is now n divided by m. So my a value is going to be given to me by 1 divided by 8. So my a value is a fraction 1/8. So let's write our formula. It's usually y equals ax, but remember our y is n, and our x is m, and then our a is what we just found, that fraction 1/8. Another way you can write a 1/8 m is to say n equals m over 8. And that is up to you which way you want to write that. For 3, r varies directly as k. Remember our y is usually in front, or always in front, should I say. And our x is always behind the varies directly. So for this one, it's usually a equals y divided by x. So our y is going to be r, our x is going to be k. So a is equal to 3 divided by 9. Now I tried to trick you on that one. I was hoping you would say 9 divided by 3 just because it was a whole number. But we're going to have another fraction here, and we're going to have to reduce it, so that is 1/3. So that's the reduced simplified fraction there. Now write your equation. It usually says y equals ax. But for us, remember we said our y is r, and our x is k. So we're going to say r equals 1/3 k, or remember, we could also say this as r equals k over 3. For 4, 5, and 6, we have to determine if it's direct variation. If so, find the constant of variation. Now your constant of variation, I wrote it over here, is the same as slope. So if it is direct variation, we're going to find the rise over the run. So number 4, I can tell this one is direct variation because it goes to the origin. That's always the important part. Now to figure out the rise over run, find another point on a good point where you can count. So it's right on one of those little crosses. And now we're going to say up how many over how many. So this one's up 2 over 1. So your a equals 2 over 1, or just 2. That is our constant of variation. Number 5, here's the origin, and that's not going through it, so that is not direct variation. That's just normal slope-intercept form. Number 6, there it is, going through the origin again. So let me find another point. It goes up 3 and over 1 to the next point. So our a is up 3 over 1, or just 3. For number 10 through 12, we want to determine if the table represents direct variation, and if so, find our constant of variation again. So this one, we're going to have to test all of our a values with y divided by x. If they are all the same, then we are going to say it is direct variation, and whatever that number is will be our constant of variation. So a calculator can make this real quick for if you need it. Sometimes you don't. Like for this first one, negative 15 divided by negative 5. So that's my y divided by my x is 3. So this is what my a is equaling on the bottom. My next one comes out as a negative 3. I can already stop. This one is not direct variation because I'm getting different a values. I'm getting positives and negatives. So that can't happen. It always has to be exactly the same. My next one, so my a values, remember that's y divided by x. I'm getting 8 divided by negative 4, that's negative 2. 16 divided by negative 8, that's negative 2. Negative 6 divided by 3, that's negative 2 again. Negative 12 divided by 6, that's negative 2. And the last one, yep, another negative 2. So that is direct variation, and our a was negative 2 the whole time. So that was my constant of variation. All right, this last one might be a little difficult. Remember, it's y divided by x. So I'm only saying that because we're going to be getting some decimals out. So let's use our calculator real quick to make this really easy. So I'm going to put in 10 divided by negative 8, and I'm getting negative 1.25. So I'm going to put in 0 divided by 3, negative 3. I'm getting out 0. So I think we can go ahead and say that this is not direct variation because we are getting out different values for our a down there. Now the only time this might not work for you, so that's why this one's kind of tricky. If that was 0, 0, it would be okay. I know it wouldn't be giving out the same a value, but that would be the origin, and direct variation always goes to the origin. All right, 2 more. The distance from lightning varies directly. So our distance from lightning is our y, because that comes in front of our varies directly. With the time, so time is going to be our x, because that comes behind the varies directly. It takes you to hear the thunder. If you hear thunder, 10 seconds, so that's time. After you see lightning, then you are about 2 miles. That is our distance from the lightning, so y. Estimate how many seconds it would take for thunder to travel a distance of 4 miles. Ooh, that one's giving us a y value. So we're going to have to solve for an x value there. So first we need to set up our equation. So what is my y equals ax? And to do that, I need an a, which is our y divided by our x. Luckily, along the problem, we came up with a y and an x together right here. So our y was 2. Our x is 10. So our a is 1/5, or 0.2. So whichever one of those you want to use. So the equation of this direct variation is 0.2x, or 1/5 x. Now we need to finish solving this problem. So I was given a new y value of 4 miles. So I'm going to plug in that 4 right here for the y and say 0.2x. And all I have to do is solve it for x. So divide by the 0.2. So 4 divided by 0.2 is 20. So you would have to have 20 seconds right there. 20 seconds for it to take thunder to travel a distance of 4 miles. I don't know if that's true or not. That's just a problem on the paper. Alright, last one. Number of calories in a container of milk is directly proportional. That's another way we don't see that very often. So directly proportional means varies directly to the amount of milk in the container. So number of calories, y, comes in front of the directly. Amount of milk, x. So we have some calories here, y, and an 8-ounce glass of milk, x. Find the number of calories. So we want the y for 8 ounces. That's our x. I think that meant to say glass of milk there, not class of milk there. So let's start by finding our equation. So we know it's directly proportional, or varies directly. So y equals ax. And all I need for that a is an x and y. Well, I have some right here together. So a equals y divided by x, or 160 divided by 8. Now 160 divided by 8 is 20 again, so a equals 20. And we've got the equation, y equals 20x. So to solve for my new part, all I need to do is plug in that 15 to that x right there. So y equals 20 times 15. And we get y equals 300.